So, welcome all to today's NFDI talk about the basic service NFDI software, unlock software, activate research data. Today we have four different speakers, which I welcome. Marc Hanisch, he works as a research software engineer at the GFZ, German Research Center for Geosciences in Potsdam. Then Oliver Werth, he works as a senior researcher and group leader for design and evaluation of standardized systems at the Institute for Computer Science in Oldenburg. Then Stefan Wittek, he is postdoctoral researcher at the Institute for Software and Systems Engineering at the TU Clausthal. And last, Michael Zacharias, he works at the State Observatory Center for Astronomy at Heidelberg University. So I hand over to my colleague Martin Reinhardt of Base for NFDI, who will give you a small introduction about basic services, and then we will start with our talk about NFDI.software. So Martin, it's your turn.
Thank you very much, Natalie. I'm glad to give this brief introduction of Base for NFDI now before the service team will take over. So, Base for NFDI is not a consortia, but a cross-disciplinary joint initiative by all 26 consortia. The idea is simple. As you can imagine, there are several IT services needed by many consortia. Examples are services regarding login services with authentication and authorization, or persistent identification of resources. And also, access to research software is a basic service. The overall goal is we want to establish and to support the creation and the development of so-called basic services. From many criteria, basic services need to meet some of them are usability for a wide range of consortia. Not just usability, but actual real added value to the consortia. Interoperability with solutions is also one of these criteria, which are part of the European Open Science Cloud, for example, the interoperability. Also, the teams are not supposed to reinvent the wheel, but to bring together and to reuse existing solutions, to integrate and to further develop those. Give funding in terms of flex funds to teams with ideas which are backed by sections in the NFDI. So this is where the working groups are and those who write the proposals. They are in the sections, and we are supporting especially those working groups and the sections with different kinds of support until they can write the proposals. And after they wrote the proposals, we are supporting through our differently trained personnel. And to pick one example from many, we support, for example, the process of surveying requirements in consortia for specific needs and shape the service and the shape of services in development. So we support with outreach activities, and this is a kind of speciality of Base for NFDI. It's important to mention that we are not a service provider, so Base for NFDI does not provide operational basic services. At the end, this will be the institutions which are creating the services. Those are the ones who provide the operational basic services at the end. So what defines a basic service? The basic service bundles all developments concerning, for example, storage and computing resources, software processes and workflows, and also the support for service desks. And ideally, this is the important part, it creates value for all users, not just users of consortia, but also for researchers in general. Also, ideally, the services should bundle existing services to reduce the development process. And also, it should have some trackable KPIs to measure effectiveness for the user and also for the service. and the use of the service especially. So how to become a basic service and how does the application process is going on? So first of all, there's a 1-year initialization phase. It needs these hands, which you can see here. This is the approval rate of the consortia assembly, and to become a basic service, you need 25% approval rate. You need a still quite low technical readiness level. You need a concept and some SWOT analysis. And during the integration and the ramping up phases, the technical readiness level need to be risen even further, and a higher approval rate is necessary. The important aspects in this is that the interoperability, interoperation with consortia solutions, and the integration of their services into the basic service during the integration. And another important aspect is during the ramping up phase, that it concentrates on sustainability, which means self-sustainability in the best case. This means business models should be evaluated and put in place. Currently, there are 8 basic services and on different levels. So for example, we have the IAM project already in ramp-up phase. And today we want to concentrate on the NFDI software service. This service is currently in our initialization phase, coming to an end at the end of October. And yeah, this is the moment when I want to hand it over to the service team, who are now presenting what they are doing and what is the vision of nfdi.software. Thank you.
Thank you, Martin. And also thank you, Natalie. I will share my screen now. Okay, welcome to our presentation, and thank you for the opportunity to give you some insights into our nfdi.software service. We are approaching the end of our first year and would like to share our ideas, goals, and achievements with you. First, we will give you an overview of our project goals, and next we will show you some demos of nfdi.software and its building blocks. Finally, we will share our plans for the next funding phase. So let's have a look at the main goals of nfdi.software. Simply put, nfdi.software is a central marketplace for research software in the NFDI. Our motto is unlock software, activate research data. We see software as the essential tool for unlocking the full potential of research data. While research software is critical for every step of the data process, from creating it to analyzing it, it's currently tough to find and use. To solve this, the major focus of our project is to make software discoverable, accessible, interoperable, and reusable, in other words, fair. We achieve this by standardizing software information and encouraging its sustainable use. By making it easier to find and reuse software, we can encourage new collaborations, ensure that software is properly cited, and increase its overall visibility. Our goal is to make nfdi.software the central access point for everything related to research software within the NFDI. So why do we think our service is an essential service? Because research software is developed and used across all research areas and domains. But as I already told, it is often scattered and difficult to find, leading to redundant development efforts. We want to create a central marketplace for research software to all consortia in NFDI. Therefore, our primary goal is to establish a cross-consortium service within Base for NFDI. We will achieve this by integrating existing independent solutions such as software repositories and search engines. These are then combined in a federated infrastructure and built on proven components. We will have a look at them in the demonstration. And finally, we will ensure integration with other Base for NFDI services. These include IAM for NFDI for authorization, Jupyter for NFDI for direct software execution, TMP for NFDI for the integration of software metadata into software management plans, and TS for NFDI for terminology harmonization. Currently, the project team consists of members from 10 different institutions that are part of 8 NFDI consortia, such as Data Plant, NFDI for Data Science, NFDI for Earth, Punch for NFDI, Text Plus, NFDI for Energy, NFDI for ING, and NFDI for Health. Today, 4 members of the team would like to introduce you to our project, nfdi.software, which is Oliver Werth from Office, Michael Zacharias from the University of Heidelberg, Stefan Wittek of the TU Clausthal, and me from the Helmut Center for Geosciences. Now let's have a deeper look at our goals. As our mission is to create a central entry point for research software, nfdi.software will improve access, usability, and reusability of research software across all scientific disciplines. We want to offer a comprehensive overview of tools and their links to research artifacts and resources. We have therefore identified 2 target groups whose needs we align our goals with: researchers who need to efficiently find and evaluate software for their research, including citation guidance, and software engineers who can promote their work and easily find and reuse and contribute to other software, fostering collaboration. So both of them have a motivation to find software or make it findable. But finding research software is a major hurdle today. You will find it listed within scientific publications, located in various public and institutional code repositories like GitHub or GitLab, or simply listed on project web pages. This fragmentation makes it incredibly difficult for scientists and developers to discover and evaluate the right tools for the specific research questions. nfdi.software tackles this challenge by significantly improving discoverability and usability. We aim to ensure that software isn't just listed, but easily understood in its context, linking it to relevant publications and providing essential details like good documentation and citation guidance. This allows researchers and software engineers to efficiently identify and reuse high-quality and sustainable solutions. Beyond just giving access to and enabling findability of software, our service is crucial for increasing the impact and visibility of research software across all disciplines. We move beyond isolated communities, allowing valuable tools to be seen and utilized by a much wider audience. This visibility is important for software as an independent research result and as an important tool for supporting research. The increased visibility directly fosters software synergies and minimizes redundant development efforts. Imagine less duplicated work and more shared innovation and cross-disciplinary reusability. Furthermore, nfdi.software is designed to enable the sustainable use and continuous development of research software. We achieve this by improving the contextualization, documentation, and standardization of key metadata. Finally, we are committed to actively monitor and align with international developments in major research data infrastructures such as RDA or EOSC. This will become even more important to ensure that our service remains interoperable, relevant, and avoids unnecessary duplication of work on a more global scale. nfdi.software potential also lies in its approach to standardize and enhance the metadata of research software. Our core goal is to establish harmonized semantic metadata. We extract, standardize, and semantically enrich this metadata by harmonizing metadata across different consortia and communities. By implementing common schemas like CodeMeta, we ensure seamless interoperability and prevent redundant efforts in metadata creation. Finally, we semantically link software metadata with other research artifacts. This means connecting software to its associated publications, research data, projects, and contributors. This contextualization not only helps in understanding, but also facilitates proper citation and reuse. We want to support this with tools like AI-based suggestion for easy metadata editing and quality indicators. We believe that this metadata strategy is important for nfdi.software's success. However, before we take a look at what nfdi.software looks like, I would like to mention the components we have built on. When we designed NFDI.software, our approach was clear. We wouldn't build from scratch. Instead, we decided to build upon and integrate existing proven solutions to create a powerful federated infrastructure for our service. At its core, NFDI.software uses the Research Software Directory, or RSD, which provides our main user interface and platform. For advanced searching, we leverage Betty's research engine, a meta search tool that connects software repositories with related publications. Physics tools enriches our capabilities by finding software referenced in scientific publications using an advanced LLM-based search. We also integrate specialized tools like the Elixir Research Software Ecosystem, or BioTools, which brings in valuable created metadata for bioinformatics. This approach allows us to integrate diverse scientific communities and their existing solutions, whether they are specialized repositories or search engines. By doing so, we minimize duplication of effort and maximize compatibility between those different solutions, fostering synergies across all research fields within the NFDI. So now, let's have a look at the current state of our service. The software page, at first I want to show you how to find software. You can get access to our service by visiting nfdi.software in your browser. Our homepage provides a direct entry point to search for software, projects, and communities. There's a dedicated software page that allows the user to browse through available software and search for it in detail. As you can see, a variety of software is listed here from different sources. You can control how these results are displayed and filtered. For example, you can sort by contributors, mentions, or by the software name. Now let's search for software that deals with knowledge in some way. You can narrow down these results using filters for keywords, for programming languages, and even for licenses. You can also filter by the software source, such as Helmholtz software or Text Plus editions. We are interested in modeling knowledge graphs, so we filter by the keyword data modeling now. This gives us one result, the Cocoda software. Clicking it takes us to the detail page of the software on a Text Plus editions RSD instance. It gives you a full overview of the software. You will find links to the software homepage, as well as to the source code repository. The detail page of the software also lists academic papers and other resources where the software is mentioned, and it also shows the software contributors and their roles. As another example, let's search for software related to sensors. We will now use the metadata keyword to find software which helps us in describing sensor metadata. This search gives us two results. One of them looks promising. Clicking it takes us to the Helmholtz RSD instance. You can see a detailed commit history and also a citation help. If a software publication is available, you can download the citation in formats like BibTeX or CodeMeter. The page also provides information on the project, its contributors, and related projects. Software from the different NFDI consortia can be added to specific communities on nfdi.software on the communities page. Here you can see some selected consortia and communities we are working with. To show the current state of the physics tools integration, we will switch to our testing environment. There, you will find the physics tools community, which lists over 40 software results. This software is harvested from the Physics Tools website at the University of Heidelberg. Physics Tools finds software that is mentioned in scientific publications. You can also filter these results by using specific community-related keywords. Now let's look at the Q2 Python package. As you can see, a lot of information has been collected from various sources, including the software repository and scientific publications where it was mentioned. But what if you don't want to run your own software marketplace? So we will now have a look at how to add software manually to nfdi.software. So first, ensure that you are signed in, clicking the plus icon to add a new software entry. The form appears where we enter the name of our software, which is Mosaic in this case, and a little description. Click the Save button to proceed, and a more detailed form will then appear. Here you can enter a detailed description using Markdown. To verify it, you can also preview the rendered text as it appears to the users. And you can also upload a logo for your software. There it is. In the links and metadata section, you can add the link to your software repository. The repository provider is then detected automatically. Information about the software, like the programming languages used, is then retrieved from the repository. Next, we will paste the Getting Started link. You can also provide a DOI for a software publication. We can then add appropriate licenses and some keywords here manually. But if you provide a publication, then the contributors, keywords, and licenses can be retrieved from it automatically. So let's add some more keywords here. And then we move to the contributors section. In this section, you can add people by name or by ORCID. So let's add a contributor of the software by using an ORCID. The system will automatically populate the contributor's information. If you include an email, it can be marked as a contact person. And we can also edit the information presented here. So now let's add another contributor. Again, we use the ORCID of the contributor to pre-fill our forms. And here we go. Our third contributor doesn't have an ORCID, so we will add him manually by his name. Okay, next we will go to the organizations section. Similar to contributors, you can add organizations using the raw or by searching it by name. Let's add Office first. Here it is. Now we will search for the University of Oldenburg using its raw. We found it and we have added it. In the mentions section, you can add reference papers. NFDI.software searches Crossref, DataCite, and OpenAlex for you. It automatically imports useful metadata from there. Other publications that cite these papers will be automatically detected, as you will see later when previewing our software entry. So now let's add some testimonials from our happy users. Just click the Add button to add a new testimonial. You can include a message and, of course, the person or source it came from. So we will add another one now. And, of course, you can add as many as you like. If your software has regular package releases, you can add their errors in this form. In the package manager section, you can add the locations for the packages. We support PyPy, NPM, Anaconda, Docker Hub, and many more. Last but not least, you can assign your software to a community. We will select the NFDI for Energy Consortium for our software here. Please note that this is a pending request and must be accepted by a community manager. There are many more options available that we will skip for now. Let's take a look at how our new software entry for Mosaic will appear to the users. As you can see, we have already found 18 mentions based on the reference papers we provided. Below that is the commit history, and next to it we will find the Getting Started link. If you scroll down, you will see all the other information we entered earlier. This includes the keywords, the programming languages detected from the repository, the license, and the links to the repository itself and to the packages. The participating organizations are also displayed. Below that are our reference papers, and you can see the publications that mention our software. Here you can also see our testimonials that we have just added, and we see the list of contributors we entered before. What is still missing is the community our software belongs to. To make this work, a community manager for our demonstration, it's me, must accept the software request. I will now do this by allowing the affiliation. And we are done. However, the software isn't public yet. So we will go back to the software entry and we will edit it again. We will simply toggle the publish button here. Now everyone can see our Mosaic software and the community it belongs to. Users can now find this software either by entering its name directly or by using the relevant keywords like simulation or the Python keyword in the search fields and filter opportunities. We now want to go into more depth, and Michael will give you an insight about the search functionality of physics tools.
Thank you, Marc. Let me share the screen. So, yeah, I'm going to present physics tools specifically. So, as Marc has mentioned, this is basically a community-specific search engine as of now. It was developed within the consortium Punch for NFDI and has been refined, let's say, within the NFDI.software project. And what it basically does, or what we do, is that we look at papers that were published, and in this case, published on the preprint server archive. And from these papers, we basically extract all web links within these papers and then put them into our database and make them basically searchable. And we assume that basically behind most of these web links, you will find a kind of software. So let's start. Let's take a look. So if we look for something, if we search something like gamma, so that top left search button is an SQL search. So you type in a string, and then you will receive any solution or any solution where the title or the name contains your string. In this case, it's gamma, and we see that any link we find there actually contains gamma, so that worked very well. What I should mention, everything that you see on the left-hand side of the screen is are GitHub repositories. And let's try to look at some of the output. So if we click there on the very first link, then we come to a subpage that basically retrieves one at the top, all the information that is basically from the GitHub repository, gives all the information there. And below, further information is provided that is, in principle, within our own database, like, for instance, the citation rate, how many times this specific link that we just clicked on has been given in papers. And below that graph, you will find the detailed list of all those papers. So if you want to look at the papers that use this specific software, you can find it there. However, the problem with this kind of relatively straightforward SQL search is if you don't exactly know how your source is named, so you look for something like gamma ray astronomy because you want to know, for instance, how to analyze gamma ray data, then the problem is such a string cannot be found because there is no string within our database that contains basically gamma ray blank astronomy in its title. So that's why we have developed two more possibilities to search. And one of them, and they're basically here. So the top one of those two is an embedded model, and the bottom one is the same embedded model, but with a language model behind it. And I will show you both now how they work. So let's start with the embedded model. Again, using the example gamma ray astronomy. As we can see on the left-hand side, we have again many GitHub links, starting at the top again with gamma pi, so that's a good fit. And on the right-hand side, we now have a couple of web links, which we define as any kind of URL in papers that is not a GitHub link for the moment. And within those descriptions that you find there, we basically then find if there's any match with our keyword, which in this case was gamma ray astronomy. Let's take a look at the very first link. Well, this leads us to this web page, which is the web page of the old satellite WMAP, which is in fact an infrared mission. So, which unfortunately has not much to do with gamma ray astronomy, so that's not really helping. Let's try the second one. That leads us here, which is the website of the COBE mission, which is again an infrared satellite and not gamma ray astronomy related. And what that basically tells us is that this embedded model finds a lot more results, but they might not be the best ones you're actually looking for. That's why we have implemented next to the embedded model also the possibility with a language model, which we do here. And now we're searching for the keyword infrared astronomy. So what it does now is it basically uses the embedded model, and from these results, it then makes a search or then refines it with the help of the language model in order to find your search results. And as we can see here, there's a lot, well, much less links found. And as we can see there, for instance, on the right side from the web links, the top one is COBE, where we just were, so that actually fits very well. The second one is to the Planck mission, which is also an infrared satellite, so that also works well. And then the third link is to the International Virtual Observatory Alliance, which is in fact well, a list or basically aggregates all or lots of astronomy data, where you will certainly also find infrared astronomy data. Let's make another example. Let's search for graph visualization. It's something that Marc also looked at. We again use the language model, so it takes a little longer to find the results. Actually, it takes a couple of something like 10 seconds or so to find its results. Here we go. So on the left again, we have all the GitHub repositories, which fit well to graph visualization. And on the right-hand side, we've got the web links, where the top one leads you to a website which has a software package GraphWidth on it, which is an open source tool for visualizing graph and networks. So that's an excellent fit. Why it takes bit of an issue. I mean, what we have seen is that the results are not yet perfect. The reason is that we use, as of now, a relatively small language model with quote-unquote only 3 billion parameters. It allows us to run all our results here on local machines, which are basically just CPUs, and within a reasonable amount of time. We also have a larger model with 14 billion parameters available, which finds better results, much more refined results, but unfortunately takes several minutes, so would have not been well used, or would not have been very well for showcasing it here. So as a long-term, or as a near-term future, we plan to actually implement this kind of searching on GPUs, where this can be done a lot faster and much more refined than what it is now. So that's basically the functionalities of physics tools. So thank you very much for your attention, and I hand over to Stefan.
So, hello everyone, also from my side. I want to present today again another way of looking at searching, but this time with a little different goal. And thus far, we've answered the question how to store and present the software that was listed within NFDITalk. And we've looked at the different ways to search within these pool of software to find the one that's fitting. But the question that we want to address is the question how to find software that needs to be put within the NFT software. And the idea that we are following here is to have an intelligent search recommender system, which we can directly, in a later integration phase, hook into the search mechanism, and that goes out and looks into the open if there is software out there that is still relevant but just not listed. The idea and what we have prototyped thus far was using an existing meta search engine, which is the one shown here, Betty's research engine, which was developed within NFD software, so that it can fulfill this role. Why are we using this this technology as a basis? Well, first of all, it's already a meta search engine capable of looking at many different sources for software. And secondly, it is also capable of looking at software repositories not in terms of software repositories, but in terms of their scientific interest. And one substitute that we are using for this is the number of citations that adhere to this particular software directory. That's what we call a cascading search, and that we are able to do already, and that we are already doing on the fly. So the service, not this prototype, but the service is already public, and you can already search there for software, and it's already cascadingly enhanced with the citation results that we get from sources like OpenAlex and so on and so forth. You will see this in a second. So what do I mean by having an intelligent search recommender? Imagine that you are looking for a software within RSD. Let's say you're looking for seismology. Then what we will do is, and what we have integrated now is that we are first doing a search within within the NFT software, which are those results. Currently not the right icon, but those are the ones. And as you can see, in the meanwhile, we're performing this cascading search, going to GitHub and taking, again, informations from different sources, like OpenAlex and so on and so forth, to see if those softwares are mentioned anywhere. The result that you get out of this is a list which contains both software that is already listed, like, let's say, this hybrid MT, which is cited over 200 times, and it's in conjunction with software that we just on the fly found on, in this case, GitHub. For example, like this OBSPy, which is actually quite relevant for seismology. The interesting thing now is, okay, there is something, and I know it's not listed, as I can see here, and I am at the moment the user who is actually searching for this, and I maybe see that this is an important software. So we have a point book where we can say, okay, that person can give us valuable information that this is software listed. And the goal is to allow this exactly through the search mechanism by saying, I guess that happens in a few seconds in this video. Let me just skip this a little. Well, for this entry, you will see all the information crawled from the repository. And you have then, that's our vision at least, at the end also this opportunity of this submit button down here, where you can then say, let me just scroll through this point very quickly. Okay, this is the information that the meta search engine was capable of crawling out of this repository and out of the publications that are linked to it. Now let's go and send this over to the NFD software, where it is then put into a curation process and can be listed also in one of the communities, and so on and so forth. So that's the current status of the prototype. And for the next phase, after initialization, we are leaving initialization quite soon, hopefully getting into integration. We plan to take this functionality out of this search mechanism and put it directly into the search mechanism in the RSD infrastructure behind that. That's it for my presentation, and I guess I hand back to Marc.
Yes, I will share my screen, and Oliver gives us some insights about the next phase.
Well, thanks, guys. I just wait a second that Marc can share his screen. You've seen a lot in the last minutes and a lot of possibilities to include software, for example, in the NFDI software marketplace, and also the connections that we have with already existing solutions and software repositories from different communities. So we are quite happy that we have some kind, I would say, a prototype. It is running and is ready for use. It has its fallbacks, of course, but in the last months, we took several efforts in making this prototype usable and useful for the academic audience in Germany to some extent regarding the first connections to different software repositories, for example. There's, of course, still a lot to do. And let's assume Stefan already outlined some stuff that we can do in the next phase. So also these base services are centered around a 3 steps approach, which means that we are currently in the initialization phase, which is a 1-year phase for these base service. Anyway, we submitted in the last months the integration phase proposal. So we are quite interested in pushing this marketplace further and provide a more meaningful service for the research community in Germany. So the focus of the integration phase that we applied on is from one case maintenance of the service on a long-term solution, further service integration from different viewpoints, and dissemination to the academic audience. We would like to start, if our proposal gets accepted, in the 1st of February, so we can take up these 3 major pillars in terms of maintenance, further service integration, and dissemination. On the next slide, maybe Marc, you can go one step further. Thank you. I outline a bit the potential work packages that we are aiming on in the integration phase proposal. Of course, as Martin already showed the general overview within base, there are much more base services that NFDI software can be value on. Also, vice versa, other base services can value from the NFDI software marketplace. So let's assume the case of Jupyter for NFDI. Jupyter, quite well known in software engineering and also software development. It's a quite useful tool. And in the next phase, we want to go in touch with them and integrate the possibilities of the base service Jupyter for NFDI with the NFDI software marketplace. Also, and this is something that we should take care on, we have and we are interested in raising our technology readiness level of the NFDI software marketplace. Of course, we have quite a good status quo, but there is still room for improvement in several ways. Let's assume some kind of a measurement of usage metrics of the NFDI software marketplace, and also service quality standards, and also the NFDI software marketplace is some kind of a software, which needs, we should take care of potential quality standards in accordance with the rules and the regulations that base for NFDI proposes to the base services. And we have to take care of maintenance of RSD, for example, and also the underlying repositories where NFDI software, the NFDI software marketplace is connected with. As you know, interoperability and also software metadata is quite of importance in this domain. And with domain, I mean the field of research software in particular. So Michael also provided some outlines regarding the usage and the implementation of AI models into the software marketplace, and also in this case of physics tools. And we want to go further with that. So we want to be interoperable with other repositories, let's say, and underlying metadata is some kind of a crucial point that we should take care in this, we call it work package 2. Next slide, please, Marc. Also, this base service lives and survives with the participation of the communities we are attending on. So we created, or we will create in the integration phase, a well-structured incubator process that is quite known from other base services now. It's a tested tool, I would say, a tested governance structure that we will reuse for our own purposes. So in the case of NFDI software, Marc already presented this idea of different communities. Let's assume you have already a repository, maybe in your institution, and you are quite interested in connecting your repository that you already have, that is already running, with the NFDI software marketplace. Because if you have the connection to both marketplaces, you will reach a more findability, of course, and in the end, also reusability in terms of the usage of the software that is input in the software marketplace and the connected software repository that is already existing. So if you are interested in such a development effort, we can offer structured incubator processes where you can get in touch with us, where you can get information about the technological backends that the NFDI software marketplace is built on, also the software metadata standards that we are currently using. And we also can provide them some guidance and help in terms of an RSD-based instance. Also, we are dedicated in this integration phase proposal and community building, and actually this NFDITalk is such kind of thing in terms of community building for maybe with a focus on a national level, but also we have and we aim to the international dissemination of this NFDI software marketplace, and also training possibilities for the audience how to use the NFDI software marketplace appropriately, most effective. And also we are quite interested in a potential EUSC connection. Marc also dropped the project of ELEX here, the initiative on an EU-wide level. And in the next phase, in the integration phase, we want to get in touch with them more in detail, and potentially find some synergies between the project and the initiatives on an EU-wide level to the initiative that we have here on a national level in Germany. Also, as Martin presented the 3 steps approach from base, which ultimately lead to a ramp-up phase, we will take care of this and a potential ramp-up phase proposal in work package 5 that is also dedicated on project management. So that was some kind of an outlook and a wrap up of this introduction and also of this presentation here in the NFDI talks from NFDI software. And we're looking forward to the conversations and discussions that we will have in the next minutes. Thank you.
So thank you very much to you 4 speakers for this interesting talk. With that, we say goodbye to our folks on YouTube. The next NFDI talk is in exactly 2 weeks and will be with the Landesdatenschutzbeauftragte of Thüringen, Tino Melzer, and it will be about data security. So goodbye on YouTube. Okay, so the stream has ended and we can now come to